In this edition of the podcast, we've got a question for you involving a tug-of-war game. We've got two people playing tug-of-war, and it looks like we've caught them in the middle of the battle, and it's a tie. Both people are tugging with a force of 500 newtons, and keep in mind that when you play tug-of-war, it's not just how hard you pull the rope, it's also how much grip can you get on the ground, because your source of strength actually comes from your legs as you push off of the ground, and then you try to pull the rope to tug your opponent. So both people tug with a force of 500 newtons. The question is, what's the tension in the rope? Is it 0 newtons, 500 newtons, or 1,000 newtons? Well, before we give you the answer, let me have you look at something similar. What if you just tied a rope to a wall and tugged with a force of 500 newtons? It'd be pretty easy to say that if the rope's tied to a wall and you tug with a force of 500 newtons, then there's going to be 500 newtons of tension in the rope as it pulls on the wall. But don't forget about Newton's third law. If the rope is pulling on the wall, then the wall is also pulling on the rope. Since the forces must be equal and opposite, the wall also pulls with a force of 500 newtons. Well, all of a sudden, these two pictures are looking pretty similar, aren't they? It doesn't matter if it's a wall pulling with 500 newtons or a person pulling with 500 newtons. The tension in the rope is 500 newtons. One more way to look at it might be to draw free body diagrams. When in doubt, sum forces. Let's look at a free body diagram of the person on the right. Obviously, you've got normal force and weight balancing each other out on the ground. We'll simplify the force applied to the ground as friction, giving you the grip to pull on the rope, and then as you look at the person, the rope pulls the person in the opposite direction. Now, if the person is going to be standing still, these two forces have to be equal. Now, part of our given information is that this force is 500 newtons because anything you tug on the rope, you've got to get to the ground. It's just the mechanics of tug-of-war. So, if we want the person to stay in place, this force has to be 500 newtons as well. Now, if you said 0 newtons, you might have been summing forces on the rope. Here's a free body diagram of the rope. We've got person 1 and person 2 both tugging on the rope. 500 newtons this way and 500 newtons the other way. The net force on the rope is in fact 0 because the mass of the rope times the acceleration of the rope equals 0. And we can see that these forces working in opposite directions would cancel each other out. Here's a key thing. Notice that neither of these forces is tension. This is the force of the person pulling on the rope. This is the force of the other person pulling on the rope. If the rope is your object, you can say that the net force is 0. But that's something different from saying the tension in the rope. Tension is the force with which the rope pulls on either person. And if you want to consider that, you've got to isolate the person. Their force pushing against the ground, the rope's force pulling against them, the tension in the rope is going to be 500 newtons.